No. Well, I'm not Miss Munoz. Okay. So we're going to start off with just reiterating what happens with ionic bonding. Okay. So ionic bonding, what was the key word that we like to use? Okay. Transfers. Yes, sorry. Okay, so deals with transfers of electrons. Okay. Now, the reason why these transfers of electrons occur is because there's a huge difference of electronegativities between atoms occur. Okay, so typically, like your metal, if we're talking about the metal will have a low electronegativity, but then the non-metal, or whatever anion is going to be formed, usually has a high electronegativity. So as a result, there's a pretty big attractive force in one way or the other, depending on what you're talking about, because of that electronegativity difference, okay? Now the other thing too, ions arrange themselves based on the maximum attraction of positive and negative charges. Bless you. Okay, so electrostatically, okay, electrostatics just meaning like positive and negative little charges, how they work in like electricity type of principles. Okay, positive and negative charges really like to attract each other, and that's why ionic structures are very, very strong. That's why they're solid for the most part, because their ionic attractive forces are so tight that they actually won't be that separated, much similar to like a liquid or a gas, let's say. So they're very much so like a solid because of that reason. Okay, so they like to arrange themselves in a crystal lattice structure.
Crystal lattice?
Crystal lattice structure. Okay, it's a very nice word. I like lattice. It's a pretty word. Lattice.
I hate lettuce.
Lettuce or lattice? Lettuce depends on the type. Okay, so crystal lattice structure, this is what it is. It's a 3D repetitive pattern that can take on predictable structures. All right, so not that you guys are going to be expected to like actually know any of these molecules. However, though, I do believe it's an inorganic chemistry, probably second year, that you actually kind of go into the details of this, and they bring out all these models. We unfortunately only have it for the ionic bonding, but otherwise this is what would happen, for example, with sodium chloride. Okay, so sodium, remember, is positive Na, and then chloride -1. Okay, so in a situation like this is what would happen, and this is what allows for this to be so attracted to each other. It's because those positive and negative charges. Ooh. So we're making a little cube, sorry. Negative. Ugh. Okay, so if you have the... Wow, that's not the best cube. Pretend it's like a cube, but not... Yeah. Okay, so in this case here, this is how sodium chloride actually gets together. So if you have a positive sodium here, okay, attached to it would be another chloride negative charge. And then that's what is going to make that really strong bond between those two atoms, okay, because one has lost an electron, one has gained an electron, okay. So sodium chloride coincidentally takes on what we call like a cubic shape, okay. So a cubic shape is like the name indicates. It forms like repetitive cubes and cubes and cubes and cubes of the exact same like structure pattern, okay? And that's exactly what's the premise of these these crystal lattice structures. Okay, now not everything is going to turn into a cube, just depending on how it actually forms out. But sometimes you can get like little triangle linkages, or you can get you know, octagon kind of little linkages and things like that. Just depends on how that molecule is actually kind of structured in terms of the ionic bonding. Okay, yes, Matthew.
What's inside of those circles?
Where?
Like on your cube.
Positive.
That? Positive and negative charges.
Yeah.
Okay? Alright. So, other substances, okay, so one thing too that you want to point out, or kind of piece out about the ionic bonding, is the fact that they have very high melting points. So what does it mean?
Means like it can tolerate a lot of heat.
It can tolerate a lot of heat before it even bothers to turn into a liquid, okay? So because of these positive and negative charges, like being so attracted to each other, it's really, really, really difficult for us to like loosen up those bonds even, okay? So they tend to have really high melting points, and therefore these tend to have like really, really high heat tolerances for that, okay? And that's one of the reasons why ionic compounds are solid in nature, okay? All right, so finally the last thing too, if you're ever talking about ionic bonded substances, all those like little crystals that you see like at, you know, Lake Louise and all that fun type of stuff, okay? Most substances are like the rocks and minerals that you'll actually find in most of our like rocks, okay? So basically all the ionic compounds, so like those pretty like quartz and like malachite and all this type of stuff, tends to be like ionic bonded type of substances, or they're ionic compounds in that form.